Check 1, 2. Here is my microphone. How is my audio? Please let me know in chat. I will be beginning in approximately 2 minutes. Thanks so much. I think I might be quiet. You're going to all tell me I'm quiet. So that's what I'm guessing I'm going to hear from you. It's like based off the number of bars I'm seeing. Sound. All right, I have pumped up my volume a little bit, so I have a feeling now you can hear me, and I will be showing you my face in just a moment. I'm not exactly prepared for this, but what are you gonna do? Here we are. The train is pulling into the station. It is me, Dan. Welcome. Coding train time. I see my image over there. I see chat messages scrolling by. I see way better, works for me. From Colby, James says much better voice, maybe still slightly low. I don't know. It is what it is. There is a dial over here that I can turn to make myself louder, but I'm a little bit hesitant to do it just at the moment. Welcome. Happy Monday. I don't have a watch on. I keep looking at my watch to know what time it is. Monday, 4:05 p.m. Eastern. This is quite possibly the worst time energy-wise for me to stream, but it is the time that happens to work for me this week today, although good news, second stream coming Friday. So this will likely be part 1 and part 2. And I just have to say, so long story, but there is another dog who is staying with us, who is not Gloria, who is behind a door over there, and I hear whimpering crying. Her name is Bailey. I might have to let her out in a minute. But I'll see about that, maybe especially if I go over to the whiteboard. So I've been working on my setup. Hopefully you can see the fruits of my labor, some nice bright lights, a really excellent keying of my green screen background. I believe I could show you what it actually looks like without the key. I had a little button for that I don't see where it went anymore. Me green. There we go. So looking at this, you would think like, actually, that's not so great. It's a curtain. I kind of got to tighten it, some shadowing, but good enough. Someday I'll have some machine learning model that will, in real time, just segment me out. But until then, green screen. I also have been working on my whiteboard shot. So let me attempt to switch over to there. I think it looks much better. I got a new tripod, so the actual camera is a little bit higher. My pants actually showing in the shot, almost. And I've been working on focusing the lens. So I definitely plan to draw some diagrams today. Let me know how this looks. Could still work on the lighting. It's probably very echoey over here because I have no sound blankets here. And I still need to put up some sound foam on the ceiling. But there's a lot of work going on right now to get this studio going, where I will be spending a lot of time starting this coming January. Currently, I didn't mean to show you that just yet, but that's fine. I am hoping that by this spring, the coding train will be entirely solar powered. So wait and see. We'll see if I can get there. Currently, I am running off of the grid, whatever power is coming to me from central Hudson, because I am upstate in New York, the Hudson Valley. But I am working, well, I'm not doing this because I'm completely incapable. I would love to do more, but working on replacing the roof, which is over my head, in order to have something a little more heft, so that solar panels can then be installed, and then I can power everything coding train wise, this whole live stream. I suppose the internet connection that I'll be getting is sort of powered from some other location coming in through here, but I'm getting too off topic. I've got to get started on what I have for you today. So Colby says, I like this whiteboard setup personally. Works better than you might think, says Zero Control. And Martin says, I just decided to give up my Tensorflow exam revision and watch this live stream. Terrible, terrible decision, Martin. No! If you have real work to do with real studying of actual educational content, I highly suggest you switch over to that. I don't want anyone's test or grade or homework to be displaced by my shenanigans. I'm hoping that whatever I do today will eventually turn into an edited tutorial video or a something more than whatever it is I do today. So let me get a couple of things. I'm just going to jump right into the code stuff. I won't be doing community contributions or some of my other more wackier segments today. Francello asks, is this a permanent studio? Well, I have changed my studio so many times in the last bunch of years. I'm trying to figure out, there must be some like coding train anniversary coming up soon because I'm doing this for a while. But this is what I hope will be a quite permanent studio, and certainly I'm going to be, my plan is to be incredibly active in working in here, somewhat full-time-ish starting in January. Well, I have a little sabbatical from my job at NYU. So get used to it, people. I hope you're going to see more of me coming in January. Now, yes, before I get going, let me just thank today's sponsor of the Coding Train. That are my friends over at Brilliant. Do you like learning? I like learning. Do you like watching me on YouTube? Guess what? If the answer is no, if it's yes or no, I have something for you. Brilliant. And the reason why is maybe the way you like to learn is through interactive lessons, and interactivity and trying things out on your own. So it's one thing to listen to me, blah, 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 autoencoder, neural network, blah, 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 blah. It's another thing to actually get in there and try it yourself. I'm sure you know this from how it is to learn to code, but Brilliant is a website, there is an app, a wide range of courses all through the sciences, computer science and physics, and they have this brand new updated version of their logic course. So I'm gonna come back in the middle of today's live stream and start the new logic course and see how it is. You can sign up for free at brilliant.org/codingtrain. That lets them know you found it for me, and that's a good thing all around, win-win for everybody. It's free, but you can also unlock all of the premium content, all of the courses. If you use that link that's right above me right here, you will, the first 200 people to do so will get a 20% off of the annual subscription. Finally, two-monitor system is giving its best, can see video and chat file at the same time. Lee Shala says, what is a sabbatical? Yes, I have worked my hardest over many years teaching my classes, 7 years to be exact. And as part of my teaching contract, I get a semester without teaching any classes and to work on some research projects. Although I will say, guess what? My primary goal, if I'm being perfectly frank, is not the coding train. Now you might be like, what? You have a sabbatical and your goal is not the coding train? First of all, it's my own mental health and sanity is probably my primary goal, as it should be for you. But I have got to get this Nature of Code book off. By the way, I'm just looking at my tripod, and even though the camera is level, the tripod is so askew, and then the top is is that not gonna fall over? Who puts this studio together? This is insane. Okay, I'll have to deal with that later. That's really looks like it's gonna fall over. You can't see it. Everything seems fine to you. I think it's going to be fine. Nature of Code book. I have got to get that second edition of the Nature Code book out, published, new website, new print edition, new examples, more machine learning. I don't know, maybe there'll be an autoencoder in there. Probably not really part of that book. But that's my number one goal is to, I've said I'm going to do that. The Nature of Code book actually came out, I think 10 years, in 2012. So it'll be 10 years. Do you know when I started talking about doing a second edition to that book? I don't even want to know. 2015 at least. So here we go. All right. So I've lost my rhythm in terms of what it is I actually do on these live streams. I'm trying to return to my roots, which is essentially if I have something that I'm trying to learn or teach, and I have not had a chance to explore that, doing it while live streaming is the perfect thing for me to do. So that's what I am going to do today. And the topic that I am going to explore is an autoencoder. Now look at this. Building autoencoders in Keras. Saturday, May 14th, 2016. What was I doing in May 2016? I'm trying to think. I don't remember. Let's see. May 2016 coding train. Can we find any videos that I was producing then? May 30th, object-oriented fractal trees. Oh, guess what I was probably doing then? Working on updating Nature of Code book in P5.js. Oh, that's so sad. Yeah, look at this, reaction diffusion. Oh, those were the days when I used to do all these coding challenges. It was another time back then. Anyway, I think I don't know if I actually probably did not encounter this article around then. I probably encountered it a couple years later, a year later. This Building Autoencoders in Keras is a guide that I'm going to use, and you might be wondering, like, wait, what? What year is it on a meme? Insert here. Because if you have been following the landscape of deep learning algorithms to synthesize media, generate images, I mean, you know that where we are today is something more like StyleGAN 3, which is, the latest and greatest generative adversarial network that can be trained on a data set of images and create new images in that style. And we can all be sort of freaked out by the sort of hyper-realism of these faces that do not exist. And so yes, that is true. I don't, but my knowledge, as I have this journey through learning machine learning, my knowledge is kind of still like, I'm still like just taking little steps forward from those old days where I was like, let me try to at least just program in processing or in P5 in JavaScript and neural network. And I think for me, when I am working with one of these newer generative models, let's say I've never actually worked with StyleGAN 3, but let's say StyleGAN 2, and I'm trying to understand, wait, what is this thing called the latent space? Why does that exist? How does it work? How is it that when I pick these random numbers and pass them through here, I get this image? And then there's a fly, by the way, on my confidence monitor there. Go away, fly. As I change those numbers and then feed them in again, how does all this stuff work? So to me, if you are interested in working with synthetic media, working with GANs to create images, whether for art or science or whatever kind of creative expressive potential that those tools and models might afford you, if you want to understand the sort of like core basic elements of how those things work, just an autoencoder is an amazing place to start. That's my point of view. So this article, I remember seeing it and being like, oh, I think I understand what an autoencoder is, kind of. And look at this code. I remember looking at it being like, I don't know what any of this is. Keras? What's Keras? So I don't know to what extent Keras is still used as a term in the Python implementation of TensorFlow, or the Python bindings to TensorFlow. Keras is a sort of is a high-level API for working with neural networks created by François Chollet, who is an amazing AI researcher and pioneer in a lot of this stuff. it's made its way into Tensorflow.js. In Tensorflow.js, it's called the Layers API. I don't believe the Keras word is there at all. And somebody in the chat can tell me why it was called Keras. I think there's, I forgot why the name. And Martin is saying, I followed that guide to create my first autoencoder as well. The undershirt chroma key pass-through. Is this undershirt being chroma keyed? Let me just see. Oh, it certainly is. That is very distracting. That would drive me totally crazy. How about I do this whole stream? Oh, wait, hold on. That'll help. I was going to like button the top button, but let me just clip the lav mic to here. I'm probably like way louder now too, because the lav mic is much closer to my mouth. Okay, had to fix that. Jim, that totally would drive me crazy. Hopefully, it might still be there a little bit. I'm just looking at this. So I lost my train of thought, but here we are, autoencoders. So a couple things. One is I would like to, before I begin, attempt to record this session to disk. I still am ironing this out, but I bought a new streaming computer, got this big GPU in it, huge hard drive, lots of RAM. In theory, I should both be able to be live streaming to you right now, as well as recording. I screen capture both cameras all as separate video files to disk, so that if I wanted to, this session could be chopped up and edited later. I probably won't do that with this session, but I at least want to see what the footage looks like after the fact. So let me hit that button, start recording. Friendly viewers. Pedro asked, is this going to be a Python stream? No, so I am going to do this. Sorry, I'm just looking at the member chat in Discord. I would like to do this. I'm going to do this with Tensorflow.js. My goal is to eventually see if an autoencoder can be demonstrated with ML5 and the ML5 neural network, which is a sort of high-level layer on top of the Layers API of Tensorflow.js, which is all, Keras is kind of like the big source of inspiration for, but we shall see. All right, so, Christian Weckmann, how did I do? Like I would say B-, writes, Keras means horn in Greek. It is a reference to a literary image from ancient Greek and Latin literature first found in the Odyssey. So now I'm embarrassed more that I didn't know that because while I am not Greek, there's a lot of Greek in my family. My wife is Greek. My children have Greek names. We like Greek food. I haven't been to Greece. So I think I was in Greece in 2015. It was a good time. Maybe that's what I'll do in January. See you all later. I'm going to Greece. Okay, let's go over to the whiteboard and talk about kind of conceptually what's going on here. Now, one thing I should say is that, and I'm just looking to make sure my audio is going. One thing I should say is that even though I've got this new setup, which I hope the whiteboard looks a little bit better, focus-wise and lighting-wise, it's still very shaky. I don't know what I'm going to do about that. Buy a new whiteboard, tighten this one up. I don't, as I'm standing here, have any access to really being able to see the chat. I can kind of see out of the corner of my eye the YouTube chat going by. So I suppose if something goes really wrong, and now everyone's just going to troll me if I say this, but just flood the YouTube chat with sirens emojis. I might be able to see that. But at some point, I am planning to set up a secondary monitor, maybe over here or over here, where while I'm at the whiteboard, I can also see the chat and see what's going on. But all right, so let's start with just the sort of core. Let's start back to what is a neural network. That's not a good place to start. Let's start back with what is a computer? How about, I don't know where to start. I want to just draw a kind of classic diagram of a neural network, and let's think about a sort of classic image classification diagram. So what if what I wanted to do was demonstrate I'm saying classic way. Is this too classic for you? There is the MNIST data set, right, which is a data set of handwritten digits, all 28 by 28 pixels, meaning 784 pixels each. So if you watched 3 Blue 1 Browns, but what is a neural network, or looked at this Keras tutorial or anything else on the internet that's kind of like a basic, like, let's learn about machine learning. And I kind of have this like goal in my life, which I am now completely failing at, which is to never use MNIST and just try to always have other creative examples. But such is life. This is where I am right now. If I wanted to build a neural network that could classify these images, I would probably do something as follows. I would have a set of inputs, and I'll represent all of those as circles. There would be 784 of them, each one being fed, essentially, I don't know if being fed is like a good way to put it, by a given pixel. Okay? So this pixel goes into this input of the neural network here. This pixel goes into it here, et cetera, et cetera, et cetera. So this is actually not a layer of the network. These are just the inputs. The first layer of the network might be called a hidden layer. And of course there are, I'm talking about the most basic vanilla neural network right now. So while, of course, if this is image data and I'm really doing image classification, I might want to use convolutional layers, which apply like filters and all sorts of other stuff. And I have videos on that. But right now, I'm just sticking with the most basic idea of a neural network. And in fact, I'm going to make it so basic, it's just going to have one hidden layer. And this hidden layer would also have some number of neurons in it. Nodes, units, lots of different words we're going to refer. Let's be really, really unrealistic for a moment and just pretend it has just 4. Now, if what I was ultimately doing was the goal of this neural network was to take this input image, feed it through the neural network, and out the other side have a classification of the image. Is it a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, right? There's 10 possibilities. Then the output layer would have 10 outputs. I think that's 10. And as I like to do obsessively, and any of my students who take my actual classes know, if I draw one of these on the board, I can't not fill it out by connecting everything. These are fully connected dense layers. You'll hear that term in machine learning a lot. What does it mean that they're dense or fully connected? It means every unit of one layer connects to every unit of the next. So this hidden layer connects to every single output. And this is just like, is there like a fast forward, jump through time thing I could do? It's a meditation drawing all the connections. The silly thing is I'm probably just in about like 30 seconds going to erase this. So I'm not sure what the point of me going through this is. But once I start, I can't stop. It's a problem. At least I only picked 4. I should have tried to maybe just pick 3. If I just picked 3, I would be done by now. Just wait till I have to do these. Oh, okay, I'm going to stop. Maybe this is the first time in my life that I'm going to manage to stop doing this. I don't think so. Are the sirens going off in the chat? I don't think. Okay. I think I might have missed one. Okay. Don't you all feel better that I took the time to do that? I'm going to do just one input. Okay, let's say this input is also going because I think it'll be easier to explain. So now we have to imagine that every single one of these also feeds into each one of these hidden nodes. So remember, there are 784 of these. There are 10 of these. And so this is what I would say what is known as the architecture. By the way, I did not necessarily think that I was just going to start by explaining, but I have to like warm up and get into this. I don't have a watch on me. I don't know what time it is. I can't see the chat. I'm going to keep going. This is what I would say is known as the architecture of the model, of the neural network. There are 2 layers, a hidden layer and an output layer. There are 784 inputs, and then we'd have a process And the same process will be used in an autoencoder called supervised learning. So the idea of supervised learning is, let's say I have, oh, I see sirens. I think it's trolling or just for fun, but I'm going to come over here with hidden node 3. All right, I'm just, whoops, I think I'm okay. I don't think there was a real siren. I missed a connection, says Joseph. I think that's what the sirens, that's fair. That's fair. I missed a connection. All right, so presumably there would be a database of training images. And each one of those images in the database of training images, oh, you know what? An autoencoder you might consider like unsupervised learning in a way, right? Interesting. We'll come back to that. Because the labels don't matter with what I want to do. So you might have like a bunch of images of digits, right? Each with their label. The supervised learning process involves feed one of these in. What does the neural network guess? Like if you feed in the 0 digit and it guesses it's a 4, nope, that's not right. Go back and adjust the neural network according to the error and rinse and repeat. So what do I mean by adjust according to the error? I mean, I'm hand waving a ton of stuff here. I think I have probably a 10-part series that kind of goes through all of this much more methodically, step by step, and writing the code for it. But the thing that's important here is that each one of these connections is what's known as a weighted connection. So there's a weight, and I think an analogy that I've heard is that you can think of each connection like a dial, and that weight can be tuned up or down. You know, what is the relative importance of this particular input as related to some particular output? And so as you feed the training data through, if I fed in this digit of a 1, and the neural network output said 1, there's no need to change any of the weights because it got it correct. But then if I fed this next one in of a 1 and it guessed a 9, I've got to adjust the weights. And the process of doing that with large data sets over long periods of time yields a sort of optimized set of weights that would, in an ideal world, will perform well with new data that's not part of the training set. And there's so much more to say about this, but I just wanted to sort of talk through the very basic kind of process of what it means to train a neural network for image classification. Let me take a short pause here, and look over and see if there are any questions in the chat. And I also want to check what time it is. Because, so, okay, I see that there's a discussion about shaders. That was last stream. By the way, I'm so obsessed with shaders, and I do have a fantasy of doing a whole like shaders tutorial, kind of like learn shaders with me might be the title of it or something. But this is part of the course that I'm teaching right now, and I've been talking about autoencoders and generative models all semester, and I really want to have a running example that I can kind of demonstrate. So, all right, supervised means we have correct output layers. Francello. Yes, supervised learning means that you have a training data set, a labeled training data set. So you are supervising the learning process with the input data and the correct answers. Can you complete your diagram? Second question. Good resources for fast iteration of neural networks and machine learning. I don't know that actually. Sorry, I'm reading the questions in real time. I don't actually I don't know if I understand that question. But hopefully the chat people can provide some good resources. You know, if you're interested, you know, not to plug things, but I guess that's what I do. That's what you're doing. Ultimately, it's all just a giant plug for me, right? No? That's weird. Join the Coding Train Discord. Let's see if this will, that button didn't work, but somebody will post it, thecodingtrain.com/discord. It's a good place to have this kind of discussion. Laurent Strodio writes, do you check all pixels from the initial pictures? So let me go back to the whiteboard here. I believe the answer to that question is yes. So, I mean, it depends, right? This is a totally made up scenario. Now, it's been, some very smart, thoughtful people designed this kind of scenario, thought through it, and I am here just sort of telling you how it works and maybe implementing it even with like from a higher level with a library that has all the lower level details. But there's no reason why we couldn't say like, hey, I got an idea. Let's see if it works with we just do every other pixel. So yes, but the maximum, if we want the maximum amount of information from the input image, we'd be looking at all the pixels. There is something known as dropout, which is a term in machine learning, I believe, that refers to the process during the training process of disconnecting certain connections, right? I talked about this being a fully connected dense layer. We want everything to be connected, but you don't. Well, there's an issue that can happen, which is known as overfitting. So if the neural network is so good at producing the correct results for some training data set of images, it might have learned it so well that it kind of can't perform when it's faced with new data. And so allowing a little bit of noise, a little bit of kind of like mistakes in there could result in the neural network, in the trained model, having some more sort of flexibility, a little bit of chaos, if you will, to be able to accommodate newer data and not be so rigid about its evaluations. I don't know if that's a sort of helpful way to explain the concept of dropout or overfitting, but I'm sure some people in the chat will write some comments with better explanations. Okay, so I think I'm ready to move on to an autoencoder right now. I'm just coming back to check the chat one more time. Right. K. Weekman writes, it's a random turning off of neurons during training. Thanks. Okay. All right, so now, the whole point of this is I'm not here to do this. I have examples that do this. And ML5, which is a JavaScript library that is a layer on top of Tensorflow.js, has ways to create image classifiers and other kinds of classifiers and regression models and all sorts of things. It's ml5.neural network. I'll refer you to, insert here in post-production, all of the videos I've made about training your own neural network with ML5.js. And if you want to just go and watch those now and leave the live stream, be my guest. What I want to do is kind of talk about an idea. What if, okay? What if instead of image classification, let's take out this idea of image classification entirely. I'm erasing sort of things that have nothing to do with image classification, but I'm erasing just to make this point. And what I want to do is create, I'm going to say, a copying machine. Let's say that. And by the way, I didn't watch it today, but last week I watched the video from 2 Minute Papers, which is called, like, What is an Autoencoder? So I would really recommend you just turn off this live stream or come back to it later and watch this video, or watch this video later if you're kind of invested in my process here. But so apologies if I'm regurgitating any of the language or concepts from that video. It's really stuck with me. And I recall the video talking about a copying machine. So what if my goal was to create a copying machine, meaning these pixels, these 784 pixels that are fed in to the inputs, the outputs also have 784 units, and I want to see, with the neural network, I want to see all the pixel values come in and the same exact pixel values come out. You would be rightfully asking the question to yourself, well, that's ridiculous. Like, why would I want to do that? First of all, I could write a for loop. For I equals 0, I is less than 784, and I could make an inputs array and an outputs array and just say outputs index I equals index inputs I, right? So the reason why I'm doing this is not to actually create a copying machine in the most exact and efficient way. Because with a low resolution image, an algorithm to copy one image to another, done, finished, 2 seconds, turn the stream off, go have dinner, whatever, go to bed. I have so much stuff to do. But so the reason, but what if, so why? Why are we talking about this copying machine? Well, with this process, and I know I obsessively drew all of those, but I need to erase them now for me to continue. I'm looking for, I don't have an eraser, so I'm using this paper towel. It's so sad. And I'm going to sort of mirror a diagram from, I don't know if it's from that video or a different paper. So what if this hidden layer, right? You think of this hidden layer, you know, I said it has 4 units to it. What if there were some other hidden layers? Like here's another one, and maybe this one has 8. 1, 2, 3, 4, 5, 6, 7, 8. And there's another hidden layer, right? And maybe this one has 8, right? And these are fully connected layers. Oh, it's not so bad. It's only 8, right? I could do this. If I start one, I can't stop. It's really weird. Like, something strange things happen in my brain. So you can get the idea that this is also, these are also going and that these are coming in. So the idea here, like looking at the scenario, is it possible to take this input image, send the data through a neural network, reducing the amount of information, and then expanding the amount of information back out, right? This is not only a copying machine, but it is essentially something like a compression engine, or a compression, right? Could we encode, by the way, and this is called, this half is essentially called the encoder, and this latter half is called the decoder. Could we somehow encode all of the pixels of an image into less data and then decode that smaller amount of data back into the full image? Now, again, the 2-minute papers video talks about this. This is not a particularly great way to actually do image compression, right? If we want a smaller file size, for a lot of pixels, there are lots of known ways to do image compression. JPEG, the algorithms behind JPEG compression being probably the most well known. But the point of doing this is not to have an efficient image compression algorithm. Rather, if the neural network can learn how to encode essentially the features of an image, encode the idea of an image, it can then generate new images, right? What would happen, the idea of an autoencoder is if we can create the encoder and the decoder in terms of like sort of this sort of creative arts world, and lots of other things too, but the idea is generative images. What if I want to dream up new digits, new cats, new whatever? I think I'm going to create a data set in processing and just like draw a bunch of shapes. So if I want the neural network to be able to dream up new shapes, could I train an autoencoder with a data set of images, then essentially slice off the encoder? I have this trained model and start just from here, feeding in noise, random numbers, vectors, latent vectors. So I want to get into this idea of the latent space, latent vectors, but I think I'm kind of like, I'm trying to explain this. I've sort of reached the point where I think I need to start writing some of the code. We could double back to this diagram and kind of get into the reality of how it works. But this is the idea, and I feel very disconnected from you because I'm not looking at the chat and all of that. But this is really exciting. This is the foundation. I mean, again, works in a very different way. There are 2 neural networks, but ultimately the idea of a latent space, generating images, and the ability to navigate and experiment with that latent space to generate animations, of those generated images. There's so much there to explore. And autoencoder, understanding it, building your own autoencoder, I think is a great place to start to see how all of the pieces work as you then later find yourself just running Colab notebooks of big models and different things. Learning, getting used to this process, understanding the vocabulary of it will give you a leg up in kind of working with more cutting edge research into generative models. Let me see what questions I have or if there are other things. I mean, the other thing I was going to say, I think this also has some pretty interesting applications because if, so denoising, I think it's mentioned on the Keras page that I want to look at. So imagine if we train this autoencoder to copy images, essentially. So it knows how to look at the image of a 1 and kind of recreate that same image as best as it can. If it's learned to do that very well, and I pass in a very noisy image, it's like fuzzy, it's got some mess in it, like just grainy extra random noise in it, the autoencoder is trained to generate non-noisy digits. So it can actually work as a denoiser because it will take that input information and try to create its best approximation of it, but it's learned how to do best approximations of non-noisy images. So its best approximation of a noisy image is hopefully going to be that the content of that image without the noise. So that's one application of this as well that you can think about. Let me go over to the chat, see what's going on, and see if we can get started writing some code. I also need to take a break and look at the Brilliant Logic course shortly. So hold on, I'm seeing some interesting, oops, and this computer went to sleep. Okay, I'm seeing some interesting comments in the chat here. Mark Booth says, really want to understand, but it gets so abstract so fast. Sorry. Lee writes, got an idea, put the board behind the camera you're normally at, and then you can look to the right instead of the left. Put the board behind the camera. But I go over there. I don't know. I have to think about that. Okay, so hopefully this has been helpful to folks. I'm looking at the time, 4:45. All right, I'm going to start. So this is my plan. I am going to generate a data set. I'm going to get my Node.js, Tensorflow.js environment set up, take a short break, and then come back and start writing the code for the autoencoder itself. So let's open up processing. What I would like to do is create a data set of images, one that is pretty sort of simple to work with. Okay, so let's call this, I'm going to just save this onto the desktop. What size is my font? That looks good. Let's save this as autoencoder training data. All right, so I'm going to write a processing sketch. By the way, look at the beautiful processing 4. Gotta love that. Let's do the following. So I don't know what would be. So I'm going to work with 28 by 28 images, like really low resolution images. Assuming we can get everything working, we can try to see how much far we can push it with more training data, higher resolution. So let's just actually, what I'm going to do is I'm going to make my processing window 280 by 280. Then when I save the images, I'll sample them down just so we can see. So let's make a black background. I'm just going to do, let's just do squares. So let's pick a random value between, I'm going to say rect mode center and stroke weight 4. And then if I said square, width divided by 2, height divided by 2, 100. Let's just try that. Let's get rid of this right now. So there we go. There is a square. So what I think I'm going to make it a little bit thicker. Let's make the stroke weight 8. Because again, I'm going to have to sample it down. I mean, why not? Make it 16. So I think what would be interesting is to ultimately do a data set that's many different kinds of shapes. But let's just do squares. That's 100 pixels. So let's have a value between 100 and 200 and use that as the width. So this is, sorry for the flickering, but now I want to save all these images. So, but I want to say, and I'm just going to say no loop, just to do one right now. So let me, and I'm sorry that I'm coding, standing in front of the code, so we'll move this over here. So let's do, I think I can use get, pimage, image equals, can I just say get? Save square dot, should I use a PNG or JPEG? I don't know. Is this going to work? Let's just see what happens. So I run this. Let me go to the folder with this processing sketch. Yeah. So that worked. But the reason why I wanted to make a copy of it is then I should be able to say image.size, resize. I think this is right. So basically I want to draw something in processing. Then I want to just create a copy of that image, resize it down, and save it to the... So let's look at this. Yeah, you can see it's fuzzy looking because it's now a very low resolution 28 by 28 image. Fantastic. So I want to do this multiple times, and I gotta, processing has this really nice feature. If you use save frame, it will like number all the images as you're saving them, but because I'm copying it using save, I could just use frame count though. So I think I could say plus number format frame count 4. I think number format will always give it 4 digits. You know, I don't think I'm going to make more than 1,000, so let's just do 3 plus dot PNG. And let's put that, let's make a folder called data. So this should be saving every image in a data folder numbered according to the frame count, always formatting the number always to be 001, 002, and let's see what happens. I mean, it's going to bother me that the first image isn't 0. Let's run this. Apologies for the flickering. Oh, no, I have no loop. So let's see. Yep, square. Oh, that really drives me crazy that it's not square 000. I'm sorry, I have to use my own counter. I mean, let's do counter equals 0. Let's change this to counter. Let's say counter plus plus. And then let's just do 100 images. If counter equals 100, exit. So now I'm going to run this sketch. This is a really simple processing sketch just to generate 100 images of squares to train our autoencoder. And obviously, I'd like to do something better now. So I'm like taking a look at the chat. Okay, so let's see what happens here. Right, we should get 100 images. I exited. Let's look at the data folder. And we can kind of scroll through this. And we can see here are my 100 images. All right, so that step 1, create a training data set of images, just squares. I really want to also make them circles. No, so one of the things that I have learned is that as tempting as it may be right now for me to build a more sophisticated scenario example, I just want to know that my code works, even if it produces a sort of obvious and trivial result. So if I can get whatever I build to produce a very obvious, trivial result, then I know that things are in the right place and working, and I can try to start exploring with more complex data and more complex scenarios. All right. So next step. So step number 1 is create my training data image set. And I'm looking at the member chat. Yes. Simon is giving me some good advice in there. I'm sorry, I don't have, the Discord is like really, really small. So I don't see it too well today. Apologies for that. Okay. Now, what is next? What is next? You know how people used to make all of these like weird musical remixes of my videos? That doesn't happen anymore. Has the internet, did TikTok happen and nobody wants to make weird musical remixes of my videos anymore? Come on, people. It brought me so much joy. It brought the world so much joy. song. Okay. What was I doing? I believe okay. Let us go now to my terminal window. Okay. So I'm going to go to the desktop. I'm going to make directory Autoencoder tf demo. All right. So now what I want to do is write the code for the autoencoder. Now, ultimately, what I would love is to someday open up the P5 web editor and demonstrate the autoencoder running, visualize the training process maybe, then generate new images, have sliders to play around with all the latent vectors. But I'm at the beginning of my journey understanding this, and it's sort of, I don't know whether it's fortunate or unfortunate for you, but what I often try to do with my videos is come from a sort of high-level place and use a lot of other tools to demonstrate a concept and offer the audience a chance to explore that concept with their own in their own creative direction. So I think eventually it might be nice if I kind of have a lot of pieces ready to go in a video that can be right at this part where people can kind of make their own creative version. But I want to understand how all this stuff works. I think for me, being able to just work with Node and Tensorflow.js directly without any interface will allow me to sort of figure out how the autoencoder stuff works, and then I can come back to later to see if I want to do it in the browser with more sort of visual flair. So I'm going to create a Node project by saying npm init. And I'm going to just hit enter enough times that the fact that I just hit enter and didn't think at all about what I'm doing. Good. Let's also hit git init can I change? Look at this. Git config -- global init default branch. This is new. Main. I want my default branch to be called main to match what GitHub does. Main trunk development, and then I could say git branch -m main, right? There we go. Okay, great. So now I'm in. So I also want to just keep this project as a Git repository because that way I can track the history of what I'm doing, and then at the end of today, certainly, upload what I have to GitHub, and then come back on Friday to complete this project. So what do I need? I need Tensorflow.js. All right, so import, blah, 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 import, blah, 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 import, blah, blah, blah. Tensorflow.js for Node, okay? But I guess I do tf.js-node. Okay, so let's see. So I want to install the tf.js node package. Error. No, not what it's called. You can see, by the way, that in case you were thinking did I do all of this earlier and now I'm just rehashing it? Clearly I did not. I think I have to do this. There we go. So I think I'm now installing Tensorflow.js node. Is it time for me to switch over and use ES6 imports? I think it might be. So I'm going to try doing that. And I'm not going to do the GPU. I'm not going to do this with any GPU stuff. This might take a little while because no, it didn't. Okay. So also, let me open this up in Visual Studio Code. Yes, so here I am. And all I have so far is a package.json. So you can see this is the name of my project, the version. I might call this version 0.01. And maybe I'll give it a description: coding, train, attempts, autoencoders. So I recognize that some of you watching might not be familiar with Node.js or Node programming. This is not as sort of friendly as me just opening up a processing sketch or a P5.js web editor. But ultimately, I'm creating a project, a software project built in JavaScript. This package.json file is the sort of configuration of the project. It's telling me, I don't know why it wants to do this, that the it's telling me that the file to run the code for this project is called index.js, and one of the other JavaScript libraries it's using is Tensorflow. So let's create an index.js file. Let's just say console.log hello autoencoder. And then let's go back to my terminal. And I'm going to say run it by saying node index.js. And I'm seeing that console log. So I am executing JavaScript code from the console via node.js. And this is going to be, because I'm importing the TensorFlow library, I'm going to be able to write in JavaScript hooks into the TensorFlow machine learning library in here and program my autoencoder. And in theory, like I should be able to some sense, just kind of really follow this and like port this code, which is sort of Python Keras library, into JavaScript with Tensorflow.js. Okay, close this. But where am I? So I think I want to, just as an experiment so typically what I will do is next say something like equals require, and I don't even know if this would work. Would this work? Like this is what I would typically do next, which is require the package and take basically everything from that library and put it in my own variable. I'm just curious. So that seemed to have worked. I'm curious what this weird messages is giving me. TensorFlow binary is optimized with one API deep neural network library to use the following CPU instructions to enable them in other operations. I don't know. So this is telling me about how I built TensorFlow, and maybe I'm using CPU, and maybe I could do it a different way to make it more efficient. But I don't actually care about any of that because I'm doing a very much of a toy example with just a few images at very low resolution. But I am kind of curious. This is not germane to the tutorial, but I'm just curious what happens if I change this to an import. And then I think if I do this, it's going to say cannot use an import statement. And so to use import statements, don't I do something like something module? Package.json ES6 module import. What do I put in it? What do I put input? Type module, there we go. So I can add type module, and then this is so not important to what I'm doing right here, but great. So if I add type module to package.json, that tells the Node engine that I want to use import statements instead of require, which is a newer, fancier, better way of doing it. I think, this is coming from somebody who refuses to type yarn. No, NPM. That's what I've been doing for 100 years, and I will still do it tomorrow, NPM. I like what I like. But I do sort of, the one thing I think that's important here is I'm on Node version 16.11.1, and I think the import syntax is only supported in Node version blank and above. Type module, okay. So again, not super important. And Simon says yarn isn't as good anymore anyway. See, if you wait long enough and never bother to use the new good thing, it eventually just goes away and gets replaced by something else. Lessons, deep thoughts, or lessons about programming with your host, Dan Schiffman. Don't bother learning anything new, because if you eventually just wait, there'll be something else new that you need to learn. And if you don't bother learning that, that'll go away too. Stick with Java. Never going away, people. All right. Okay. All right, I'm looking. V13 is the minimum version for ES6 imports. Okay. It took you 3 years for var to let. Yeah. All right, so now I believe I am set up and ready to go. Oh, there's a lot to be done here. All right, I'm trying to think. This is probably a good pause time. Oh, a couple things. One, let me take my images, this data. Let me go to this folder. Reveal, can I do like reveal? Come on, reveal in Finder. Let me put this data folder here. Okay, so I'm gonna throw this project up on GitHub real quick so people can take a peek at it. But one thing that I want to do before I do that is I don't want in my Git history the images to be there. So I'm going to, if you are someone grabbing this code and wanting to run your own version of it, you'll need to generate your own images or download sample images from somewhere else. I don't want that polluting my Git repository and Git history. And I also don't want the node modules. So I am going to create a .git ignore file. And I'm going to put the data folder in there, or maybe I could also just do star.png. It's different ways I could do it, but I don't know which matters. I'll just do them both. I don't want the node modules folder, and I don't have any environment variables yet or anything like that. I mean, I could add that in just in case. These are some sort of standard things. I also, like, nothing bothers me more than the Mac OS DS store files. So this is some pretty good git ignore stuff. I'm going to say git status just to see where I am. Let us add all of this stuff. And I'm going to say initial project setup. Let's go to github.com. Oh, no! I'm not signed in. If I'm not signed in, this means you're going to have to wait about 45 minutes for me to do like all of my various randomized passwords, lookups, and two-factor. Oh no, look, it's saved. All right, it's not so bad. So I just have to do my two-factor. I forgot that I did that for my streaming account. So let me just get my authentication code. I'm going to just move over to here. No reason for you to see me type it in. One. Oh, I don't care. You know the first digit is 1. Okay, I'm in. I am going to make a new repository. Let's put it in the coding train org, Autoencoder demo, public, create the code from live stream. Started, what's today? 11/15/21. Let's create this repository. And I can just add, I don't need to do, this is showing me instructions about how to link my local repo on my computer, but I've kind of done, oh yeah, I could just go right here. So I can just add this repo as a remote. And then I can send it along. I don't need to worry about the branch. I've already made my branch main. And so now, if you are following along, I need to add a README and do more. The code so far, the project configuration is here on GitHub. Put the whiteboard facing the green screen. Oh, but it would be in front of the camera, behind the camera. So I'd walk over there. All right. The camera's actually quite far from me. Like, if you don't realize, I have to walk all the way around, walk over some cables and stuff, and then here I am at the camera, because I like a wide sort of view. But anyway, I'm taking your suggestions, putting them in my mind. So it is 5:07. I am going to be streaming until 6 o'clock. So I think we have some time to get started on the actual TensorFlow code. And I will be returning this Friday to complete. This is, by the way, this is the new Dan. I'm just going to see how, I'm going to give myself a lot of time. Remember, I'm going to do shaders and autoencoders and look at community contributions. And then I'm going to also demonstrate this whole other fractal pattern that I just learned about yesterday from watching a 3 blue 1 brown video. All in 45 minutes. No. I'm starting this autoencoder project, getting as far as I get today. I'm going to turn this off and come back, and I'm going to continue where I last left off. This week is the autoencoder week. But before I get any further, I would like to take a moment to, I'm just opening this up here, I have some notes. Boy, my setup is really not the best. I would like to thank, it's coming, gonna press the button, it's all gonna work. Today's sponsor, Brilliant. Whether you're looking to learn something completely new, brush up on a few topics, you're interested in STEM, there's no better place than Brilliant. It is an interactive STEM learning platform that helps you learn concepts by working through them in visual, hands-off ways. Hands-on! Look at me reading a script. I'm so bad at it. Fired. Always fired. Let me tell you, I know that I'm reading from the script here, but I actually really love Brilliant. And one of the things that I love about it for me right now is that I do it with my kids, because my daughter is learning how to do factors with numbers. I was like, oh, look, there's a course on factorization. There's little interactive lessons, and we can do them together. There's so much awesome stuff. Extensive course catalog, constantly expanding. Some of my favorite courses, I'll bring them up here. One is there's a whole course on neural networks. So do you remember this ridiculous drawing that I was trying to do to explain neural networks? Look at that. Look at that. Look at this. In the Brilliant Neural Network course, you can actually read about, understand, interact with neural networks as they recognize digits right there in real time. So much to explore with that. The logic course is one that they have just completely, is all brand new. So it's the revamped edition, has new lessons, challenges, and a much higher level of interactivity. So what I would like to do, what I always enjoy to do with my sponsor segments, rather than kind of play these pre-rendered clips, is head over to Brilliant itself. And let's take a look at the courses. I'm going to, what is, factorization is in their pre-algebra. There's also a great what is a derivative course if you're interested, if you want to learn some basic math stuff, there's really, really great. Okay, so let's go over here. Sorry, I just wanted to be able to see the chat again. I lost the chat. So let's find the logic course. So I'm going to click here on the logic course. It says continue because I clicked on it earlier today and then I was like, oh, this is way too much fun. Not going to look at it. Got to save it for the stream. So let's go to continue and see how it works. Okay, so let's try this one first. Ray, Nuck, and Lex are robots from, and let me see if I can make this a little bigger for you. That's hopefully going to help a little bit. Are robots from 3 different models. Ray is not the newest. Nuck is the oldest. Lex is not the oldest. So what's the correct order from newest to oldest? I think I'm going to be able to do this one. By the way, I love these little robots. Just as an exercise, could you make your own little robot characters in P5.js? So much inspiration here. Okay, so Nuck is the oldest. So Nuck has to go here. Ray is not the newest, meaning its only other option is here. So Lex is the newest. And I'm going to check. Yes, did you hear that little ding, by the way? It went in my ear. I don't know if the sound is going out. That was exciting. Okay, let's hit OK. Go to the next one. Arrange the robots to make the following true. Loy is in one of the 2 middle spaces. Mig is to left of Lex and right of Ray. Ray is directly next to Mig. So let's just try putting Loy here. And then, is there anything? Okay, so Mig is to the left of Lex. and Ray is directly next to Mig. Okay, hold on. So what happens if I were to do this? If Mig is to the left of Lex and Ray is here, that can't work because Loy's got to be in a middle space. Oh, is left of Mex and right of Ray. Oh, but Lex could be here and Loy could be here. So are there more possibilities? So this satisfies, right? Loy is in one of the two middle spaces. Mig is to the left of Lex and right of Ray, and Ray is directly next to Mig. I have a feeling if I did this, it wouldn't work, right? Because then we couldn't have Ray directly next to Mig. So let's check. Okay, I got it right. I don't know how many of these I'm going to do, but this is like, I mean, are you not having fun? I'm having fun. One of these I'll get wrong eventually. 3 robots compete in a race. Marv and Lex do not place next to each other. So the thing is, first of all, I should know about this because many years ago, I majored in math and philosophy as an undergraduate. It wasn't a double major, it was like a combined major. And what is math and philosophy together combined as one thing? It's the study of logic. So what I love about this is I'm kind of just enjoying this right now as a puzzle, as a game. I mean, this is kind of like the stuff I love to, I don't want to name other kinds of puzzle activities I like to do on my phone, but like Brilliant being one of them, I like to just solve puzzles and play games. But what you don't realize maybe is that I'm learning all of these really important foundational concepts in logic, and I have a feeling that as we go through this course, that will be revealed. 3 robots compete in a race. Marv and Lex do not place next to each other. Ray beat Marv. So if Ray beat Marv, I think the only way for this to be true is this configuration, because Ray beat Marv and Marv and Lex are not next to each other. So the only way for Marv and Lex not to be next to each other would be either one's in third and one's in first. But the other way around, but for Ray to beat Marv, it's got to be, Marv's got to be in last. Okay. Still correct. Eventually I'm going to get this wrong. Okay. In the next race, give myself a few more minutes. Oh, I think I can maybe get to the end of this. Let's see if we can get to the end of this. Let's see. In the next race, 1 robot finishes between Ray and Lex. 2 robots finish between Lex and Ty. So if 2 robots finish between Lex and Ty, one has to be first, one has to be last. And 1 robot finishes between Ray and Lex. I think I might have just gotten it. Because, I got lucky, but let's try doing it the other way. Right? If Ty was first and Lex was last, Ray didn't finish second, but 2 robots, wait. Oh, no, wait, hold on. 1 robot finishes between Ray, oh yeah, but so Ty didn't, so then there's no robot between these 2. So Ty has to be last, yeah. And Marv has to be, the other thing about this is honestly, like, imagine programming your own interactives like this. So while this is a little meta for you, the coding trained audience, and I'm emphasizing again, like so many of my coding challenge ideas have come from working through these brilliant lessons. Got it right. Okay, we're almost there. Arrange the racers in the order they finish. Okay. Ray isn't first and Ty isn't last. Okay. Lex doesn't place next to Ty or Ray. Marv finishes ahead of Ray. So my strategy for doing this is trial and error. Like, let me put one, and because it's interactive, I wonder, I'd be curious to hear from you, what are some more methodical ways of doing this? But Ray isn't first, so Ray could be last. Ty isn't last, so Ty could be first. Probably not right. Lex doesn't place next to Ty or Ray. Nope. So Lex would have to be like, Ty and Ray have got to be in like the first 2 or the last 2 in order for Lex to be not next to either of them. And then Marv finishes ahead of Ray. So I think this satisfies everything. So Ray isn't first, Ray is last. Lex doesn't place next to Ty or Ray, correct. Marv finishes ahead of Ray. So I think I've got it. Let's check. By the way, I like seeing their explanations. And seeing the explanations, we can see from the second clue, we can conclude that only Marv finishes next to Lex. So either Lex finishes first with Marv second or last with Marv third. So the explanation is following something similar as me. There's only two possibilities. Let's try one. The third clue tells us Marv finishes ahead of Ray. So that means Lex must finish first with Marv second. OK, right? And then you've eliminated with another clue. OK, back to problem. Let's go to the next one. OK, I have 3 more. The final race is between 5 robots. Oh boy, this is getting harder now. Let's see. Ray finishes faster than Marv. The smallest difference in finishing times was between Ray and Lex. The largest difference in finishing times was between Lex and Ty. Well, that means, doesn't that mean either Lex has to be first and Ty last, or vice versa, right? Smallest finishing time just means that Ray has to be next to Lex. We don't know the difference, but obviously if it weren't next to Lex, something else. So these two give us this possibility, or I could put Lex here and Ray here. Mig finishes in first or third, so Mig could be third, Marv. Ray finishes faster than I think I got it, luckily. So I think I had a 50-50 chance, and I got it luckily, I think. Let's see. Got it correct. I'm really rocking and rolling here. Review and reflect. The key, see, this is what I mean. I was just having fun playing with a logic puzzle, working my brain. I wish my kids had been here to do this with me because they would have really enjoyed this, or they might have actually been like, oh my God, Dad, again with the brilliant puzzles? But they like it. I know they do. The key concept from this lesson is start where you have the most information. Given multiple pieces of information, start with the one that lets you deduce the most. The next challenges are a bit harder. Recognizing useful information is a skill you will hone throughout this course. Well, I want to hone that skill for sure. The next challenges are a bit harder. They'll require you to process more information and recognize what's most useful. All right, I have completed 5% of the logic course. Solve problems by visualizing relationships. Did I like this lesson? Oh, yes, I did. Continue. Abstract order logic, strategic order logic. So next time that I am doing a live stream sponsored by Brilliant, I might be much further ahead in this if I've been going on my own. Otherwise, I will return to do this. If you like what you see here and want to try Brilliant out yourself, please take a minute. I'm going to take just a short break just for a couple of minutes. I'm looking for, oh, it's already there. You can sign up for free at brilliant.org/codingtrain. That lets them know that you found Brilliant from me, the Coding Train. Yay, that's a good thing. And there's a lot that you could do on Brilliant for free. There's daily puzzles and different things. If you want to unlock all of the premium content, all of the courses, then through that link you will get the first 200 people to sign up through that link will get a 20% off description. It's not really the holiday season just yet, but I might also just make a note that buying somebody a Brilliant subscription as a gift is a wonderful thing. I mean, it's not just more plastic nonsense. It's educational and learning and fun. I mean, that's like, if you want to, I already have it, but if I wanted a gift, that's what I would want. Can you get me like the uber super awesome extra premium Brilliant? Then that you get me as a gift. Okay, thank you Brilliant for sponsoring the Coding Train, for keeping this engine going, for allowing me to set up this new studio, for helping really make all my dreams come true. You, the audience, though, mwah, I love you all. I'm going to take a short break. I'm just putting up this intermission card here. I'm going to try to just limit my break to about a minute or two. Put on some music here, just so I can check, and then I will be back in just a minute or two so I can keep working on the Autoencoder project. See you in just a minute or two. Okay, pretty short break. Just getting myself back to being set up. I suspect that nobody just happened to join at this very moment. But if you did, I am working on making a Tensorflow.js autoencoder example. I spent the first half of this live stream. And, by the way, the boiler in the garage is running, so apologies for that extra noise. But I spent the first half of this live stream kind of talking through this diagram. Oh, boiler went off. In terms of what a neural network is and what an autoencoder is and why we might want to try this and how this is going to lead to understanding latent vectors and all of that kind of stuff. So I am now right here wanting to work with Tensorflow.js in Node itself. So I need to start building the autoencoder using Tensorflow.js code. So let me go to TensorFlow. I'm going to look at the Tensorflow.js API docs. So I haven't done this in a while, and I want to use the Layers API. So the Layers API is essentially, and sorry this is so small, if I understand it correctly, is essentially the same as, I can't get to the right place. Okay. The Layers API is the same as the original Keras, just without the name Keras. So the first thing that I need to do is create a sequential model. So I'm going to do that right here. So I have imported the TensorFlow library using the Node implementation of Tensorflow.js. I am now creating a model, and do I dare I rename this to be called Autoencoder? Is that bad for some reason? To me that feels good, because what I'm doing is creating an autoencoder. It is a sequential model in the sense that it is a feed-forward neural network. The layers are architected in a linear sequence, sequential. That's why the word sequential comes there. The next thing that I need to do is start adding layers. So the way I like to do this is okay, so let's first look at this, this example. Now, I would love to sort of like read all of this out loud for all the explanation. Hopefully I gave something of a helpful explanation, but let's look at this. So the first thing that we need to do is create the input shape, which has 784 pixels. A lot of people are asking about shaders in the chat. Is it just because I did shaders the last couple times? Or is there something stray, like still in the thumbnail or the description, that's mentioning shaders that I forgot to take out? So not today for shaders, unfortunately. So interesting. So I want to create the encoder layer. And the encoder layer in this example has 32 units. So how do let's see. Basically, I want to write code that's like this. I want to create the encoder, which is a TF layer that has like 32 units. And the input, I'm making this up. I don't think this is right, is like 784 pixels or something like that. So I don't recall the syntax. And then I want to say autoencoder add layer encoder. Like this is basically the idea. Clearly I've gotten something, TF layer, like is that a function? I don't know. So now I'm just like making up code. Like I want to create this layer, right? I'm creating this layer, this decoder layer, that is going to receive 784 pixels and have 32 units. So let's see if I can actually find the right syntax for this in the TensorFlow documentation. So going back to that, which is here, tf layer. Is that like, tf layers.dense. Oh, look at this. All right, so I was pretty close. Like if I just put this in here. So I want to create tf layers.dense. So this is a function that creates a dense layer with 32 units, and the input shape is 784. So input shape. OK, great. So that's the encoder. Now, in the original Keras example, I just make, just one. So I'm going to definitely want to expand this. But this very, very basic example is just two layers. A hidden layer and an output layer. And essentially, the hidden layer is the encoder. The output layer is the decoder. The inputs, remember, are not a layer. That's the data being fed into the first layer. So on a very, very basic level here, I'm then going to create the decoder. The decoder, which has 784 units. Now, interestingly enough, ask yourself this question. What is the input shape to the decoder? I should put a poll up and have people vote on it. Is it 784? Is it 32? Is it something else? So remember, the encoder has 32 units. We're putting 784 pixels into it. The decoder has 784 pixels, and we're decoding what? Those 32 units. So the input shape is 32. However, I believe that this does not need to be stated, because Tensorflow.js, I must specify the input shape for the first layer, because how is it going to infer that? I mean, maybe it could infer it from the data somehow, but that's ML5 kind of does that, but that's not going to happen here. But the decoder can infer the input shape if I add it directly after the encoder. So I am creating my autoencoder model. It has two layers, an encoder, which receives 784 pixels, and a decoder, which pulls from the encoder to decode it to 784 values. OK. Yeah, and in practice, and I'm repeating K. Weekmans from the chat, in practice, you would have multiple encoder layers and multiple decoder layers. I'll add that in if we can get this to work. OK, input image. OK, I'm not going to worry about that. So this is right. So compile. So I forgot how to use Tensorflow.js. So I have video tutorials on how to do this, but I'm going to just right here. So what are the next thing I will typically need to do is, once I create the model, is just looking, isn't there I should look at my old examples, right? I have examples where I do this kind of thing, like Tensorflow.js, coding train, GitHub. I mean, these are probably so way out of date, but I made a bunch of examples. If I go look at this doodle classifier, for example, we can see I'm adding a convolutional layer with all sorts of stuff. And then, then I have to do this. I have to compile it. So let's grab this code here and see if this is kind of the right idea. So this is just setting up the layers, compiling the model. What is that doing? Well, it's connecting all the layers and setting all the functions that are the math for how the elements are processed. But if I look at this, right, this basic example, this is such an old example, right? The activation function is just sigmoid. So, oh, and this one is relu, which is not at all French, but I can't help but say it as if it's a French word. So if I wanted to follow this, also I missed that, I could say, and apologies for not taking the time to explain activation functions, although now that I said that, I think I'm going to have to just briefly touch on it. But I think I can put the activation functions in like this, right? Just looking at my old examples. Yeah, activation, right? Okay. So what is an activation function? So if I go back to my diagram, and there's a ton more to say about this, obviously, and some of my other video tutorials would go through this in more detail. But these dense layer connections, right? There's some number is being outputted from here and outputted from here. And remember, there's all these weights. So all of the values, all of the stuff that's coming into this particular neuron is the weighted sum of all of the units that are connected to it in the previous layer. So all of the output values multiplied by their weights, all added together, get processed inside of this particular neuron. And how do you process those things? With an activation function. Basically, the way to think about this is if you think very loosely about I was going to say like a fictional version of how our brain works, because I'm obviously not a neuroscientist and I'm not going to speak with any rigor here. But oh, my brain, all the neurons are connected and they're lighting up or turning off, and I see this delicious blueberry and I smell the blueberry, and those are the inputs, and all my neurons start lighting up, right? So does the neuron light up or not? Does it activate? So we want to process all of those numbers and process them through a function which will essentially like squash that weighted sum. Weighted sum could be some big number, small number, into some range like between 0 and 1. Or is it just a positive or negative number? Is it on or off? So that activation function, sigmoid, this now is not the time for me to start going through the math of different activation functions and why this one is used and not that one is used. I think this is reading that I would encourage you to do. Maybe some people in the chat could offer some resources. I certainly touch on it in other videos of mine. But sigmoid is a sort of like classic. If this is all about classic machine learning, sigmoid is sort of like the classic activation function, not used very much these days, but let's use it just to match this particular example. Then I was remembering I need to create an optimizer with a learning rate. Okay. So I need to compile, like this is just the sort of architecture, and now I need to tie everything together. What's a good way of explaining what compile is doing? I mean, I understand what it means to compile the code, but I don't know that it's, I'm kind of struggling to find the words to describe what it means to compile this model after I've set up all the layers. But a learning rate, is there a learning rate specified in this particular tutorial? Learning rate, space rate, no. So probably it's using a default one. Let's just keep that. An optimizer, I thought I saw in the code here, the optimizer is atom. Okay, so let's match that. I think I could just do this, atom. I think actually I probably could just do this. But I'll do it this way. And then the loss function is binary cross entropy. So and metrics, I don't know that let's just comment this out for right now. So these are, I'm kind of at the point of the day. It's like 5:40 p.m. Eastern. My brain is not functioning very well. I need to eat dinner. I'm tired. I have a lot to do. I've got to go teach my class in person tomorrow. I didn't finish this, but I'm gonna do my best here. So when I come back on Friday, maybe I can come back and sort of talk through some of these elements a bit fresh. But essentially, The loss function is the mathematical function that's going to calculate how well the network is doing. So in this case, if I'm trying to create a copying machine, how closely do the output images match the input images? A loss of 0 would mean they're exact reproductions. And binary cross entropy is a particular kind of loss function. Like, what would be something? What did I have before there? Would be like categorical cross entropy. I'm trying to just think of what. It's escaping me right now, but mean squared error or something is what I think is what I'm looking for. Okay, sorry. Let me comment this out. Okay. So let's just see if this even runs. Like, is this going to allow me to build this model, compile it? I haven't actually done anything yet, but let's just try running this node code, see if I get any errors. Okay, I got an error. Add layer is not a function. I just made up a function called add layer. Let's go back to the API. Add, it's just add. Okay, great. Simpler. So it's not add layer, it's just add. Okay. Unknown loss binary cross entropy. So that is not the name of a loss that is in Tensorflow.js. Interesting. So let's look for TF loss. Loss. Hold on. What was the one that I had in my other example? Because I can search for it. Categorical cross entropy. So let's look for it. No, whoops. Sorry, on this page. So much going on. Here are the loss functions. So binary cross entropy is the one I'm looking for. So I can just, I assume I just wrote it incorrectly because that's like the Python way of doing things with an underscore. And the JavaScript way of doing everything is with camel case. So let's see if this runs with no errors now. Okay. Hello, Autoencoder. So I realize that those of you watching this, if you've been really following this whole thing, this is very much going to be a to be continued operation. I mean, I do have 20 minutes, and in previous live streams, you'll see me scramble, be like, I got 20 minutes. I'm going to try to just jam it all in there and get it to work. Not doing that today. But let's see, I do have a little bit of time before I wrap up. Let's see if I can get a little bit further here. So let's look at the Keras code. So I need to somehow figure out now, so I could just create noisy data. What if I just made noise, like random data, and see if the autoencoder could produce random data? Would that be interesting, or should I try to first import my images? Well, the next thing is that, yeah. So this is what I need to do next. Oh, interesting. I'm like, what is going on here? This is so crazy. I'm like, where's the whys? Where's the whys? Where are the whys? I just realized, you know what? I think I can do this with fake data in the next. And then the next stream will be actually, actually using the real data. Sorry, I'm reading some interesting comments. Without activation functions, you will get PCA components, principal component analysis. Add Gaussian noise, then denoise. Interesting. Input noise. Yeah, so let's just, for a second, let's try to create some training data. So this would be known as xtrain. So just for a second here, just for, let's create let's write a function, random, I'm trying to think of what to do here. Let's consider an image to be an array of 784 values, each value being a random number. So this would be generate image. It's not really an image. Wait, why is my auto format not working? Okay. So if I were to say x input is an array x inputs index I equals generate image. So this is me creating like 10 arrays of 784 numbers. And kind of unnecessary to put that in a separate function, and I'm not really being thoughtful about how I'm organizing my code. So this is the training data. But that's just it as a raw, like if I just do console log x inputs and run this code, ooh, huh? So I have a mistake. Oh, return image. And let's just make these with 7 values just for simplicity's sake for a second, right? These are now this is my training data. And I want these images to be the image, eventually these values to be mapped to the images from processing, but I'm not there yet. So I just have array, 10 of them. But they need to be 784. And the thing is, they cannot be raw JavaScript arrays. TensorFlow works with tensors. A tensor is just a bunch of numbers with a shape, right? Is it an array of arrays? Is it an array of an array of an array of arrays? How many elements are in each array of array, right? An array is a list of numbers. A matrix is like a 2-dimensional array. A tensor is a much more sort of generic view of this. And can you input your logo? That would be interesting to hear, to try. So I need to convert these plain vanilla JavaScript arrays into tensors. And I believe the way it's like it's doing this like reshape. I don't remember how to do this. So I can look at the ML5 does, when I've been working with, does all this for you. I bet you I did it here in this example. Classifier, batch size, data, reshape. Yeah. Batch, data, oh my goodness. Reshape, fit. Ooh. Where am I making the tensors in this example? Whoa. Oh yeah, there we go. TF tensor 2D. Yeah. So that's this is much simpler than so the X train could just be TF tensor. Let me just paste this in here. Yeah, tensor 2D X inputs. Now I think like I could give it batch sizes and all sorts of things, but I think it's going to infer things correctly. And if I just say xtrain.print, let's see what happens. So this is basically, I generated these 10 arrays of 784 numbers. And then I'm looking at my watch that does not exist. It's 4 hairs till I have to go. And then I'm creating a 2D tensor. It's 2D because it is an array of arrays. Yeah, this looks good. Look at this. My memory of how to work with TensorFlow is really coming along here. I'm enjoying seeing some of the nice feedback in the chat. From Ali, thank you so much. From Anurag, I don't know if you're referring to this class or something else, but thank you. And I know that I'm kind of standing in front of, like to move this over here. Okay, So now I should be able to go back to essentially doing the equivalent of the fit function. So for example, this is Python, but I got to do this in Tensorflow.js. I'm going to fit xtrain and xtrain, and then my assumption is like these. So this is really, really weird, xtrain, xtrain. I'm going to come back to that. This is why it's like, is this supervised learning or unsupervised learning? It's kind of interesting to think about. But then I assume I would have an object that would have like epochs 50, batch size, 256, shuffle, true. And I'm not going to worry about the validation data right now. That's probably really important, but so I feel like the equivalent must be this. Now this is, and this must be as well, is this an asynchronous function? TF tensor fit is. So let me look at model.fit, the fit function. XY args. Fit. Compile. Oh, right. So look, this await model.fit batch size epochs. Model.fit the x's and the y's. That's await. But to create a tensor, the tensor is synchronous. So this is asynchronous. So I could use the then, but I'm going to do this. I'm going to write an async function called train model. And the format on save is gone. I'm not going to deal with that right now. Come back to that. Then I'm going to say await. Now there should be a callback that I can give this so that I can sort of console log the loss as it's training over 50 epochs. So I could call, and by the way, if you're like, what is await? What is async? Hey, boy, do I have a set of video tutorials to sell you. I have no magic way to make them appear here, but I'm sure if you search await async coding train, you will find those video tutorials that go over promises and all of this sort of syntax. Okay, so now I want to look for the callbacks. XY args verbose. Will it just log things automatically if I make verbose equal true? Maybe it'll log stuff automatically for me. So what I was planning to do is put these callbacks in, because basically I can have, there's a lot of them. I can have a callback on train begin, on epoch begin, and then I can look at the logs which have the loss. Let's just try running this. I turn into a pumpkin in 8 minutes. Hey, oh, hey, ho, hey, ho, ho, hey, ho, hey, that worked. What? Now, the loss didn't really seem to do anything. I mean, I am training it off of random noise. And that was like so fast. Okay, hold on. Let's make, let me give it, maybe make 1,000 random images just to make it more data. That was way too fast for me to look at. And also, I want to artificially slow it down. Okay, great. So I have a feeling that I'm not getting anywhere because I'm feeding it random noise, but I don't have any errors. So I could look at one of its outputs and make it into an image, but it would just be noise. So I have to assume that I'm doing this correctly on some level. I did one thing that I might like to do is I did in the code specify a learning rate, which was not specified in the example. So like for example, would this work if I just do this? And this will be sort of more default stuff. Just curious. Yeah, same results, but I just, there's no reason for me to get really specific about the hyperparameters here when, I'm going to put this back in. This is very exciting to see this work. Zaris Phil, why don't you apply Gaussian noise? That's a good idea. But I'd have to like write a Gaussian noise function in JavaScript. Although I think I could get one really quick. All right, I like this. I have 5 minutes. I think I might have implemented the random Gaussian function in P5. So I think I could just grab that. I know there's one in there. Source, math, noise. No, noise would be actually noise. Math, just math. No, random. Where's the random Gaussian? So this is the implementation of a random. Ugh. Bleh. Mean. Okay, I think I can manage this. Oh, but it's not really going to be Gaussian. The Gaussian noise, I was sort of thinking of. I think this is too much effort right now. It's not really going to give me. I should move on to actually generating the shapes. So, if you ever wanted to have a reason to tune in to the next live stream, which will be this coming Friday, if I had to guess around 10 a.m. Eastern, it will be part 2 of this autoencoder. Like I've got all the code with Tensorflow.js for an autoencoder right here in Node. I've spent some time explaining what an autoencoder is. I can't emphasize it enough that if you're looking for something to watch, 2 minute, this particular video will be incredibly helpful. It's just like 3 minutes long, so this will give you excellent background to what I'm trying to do to wait for Friday when I continue this. But what I need to do now is replace this generate image function with some code that actually goes into this data folder and pulls out each one of these images and translates that into an array of 784 numbers. Then will the loss, as I train the autoencoder, consistently go down, and could I start to try applying the autoencoder to some applications like denoising or generating new squares? What happens if I train it with circles and squares? Can I morph through the latent space of squircles? Oh, there's so much that could be done. But I'm going to just leave this as where we are today. This has been like the most semi-serious coding lecture live stream that I've done in a while. I'm curious for your feedback, how this compares. I'm hope we'll see what the future brings, but I doubt this is. I'm gonna hit stop on my record to disk engine. Hit stop. I'm just curious, by the way, to look at that file. I'll try to answer some questions, but the file I just recorded today is date modified 4K OBS 1115. 57 gigabytes, ladies and gentlemen and others. Sorry. Yeah, so that probably worked without a lot of, that's probably a high quality video, 57 gigabytes of the entire, all my different feeds today, if this ever wanted to be edited into a more step-by-step tutorial just from this live stream. Training on Perlin noise would be interesting. Oh, and I should probably pick another loss function. So, Kay Wiekman, let's chat in the Discord later. So maybe you can give me some helpful tips and advice of some things I might want to revisit when I come back on Friday. Let me go back to the chat to see if there's any questions I can answer before I go. Is TF slower in Node.js? So actually, this is a really interesting question. And there's no easy answers to these questions because there's so much it depends. But TensorFlow.js in Node should be faster than Tensorflow.js in the browser because it is linked to native TensorFlow. So TensorFlow in the browser is running a TensorFlow.js implementation that all the math happens with WebGL context or just the browser CPU. TensorFlow.js in the browser, in Node is running actually native TensorFlow. So what I hear is that CPU TensorFlow.js in Node is mostly equivalent to GPU WebGL TensorFlow in the browser. I don't know if that's totally true, but obviously the fastest thing I could do would be to run TensorFlow.js in Node linked to like the GPU of my computer. I don't know if I'd have to install CUDA or some other kind of thing for that, but I'm not doing that now. What type of a bunch of other questions are being asked that I don't know the answers to? Thanks everybody for tuning in. I'm just going to keep playing this song. I will be back on Friday to continue this autoencoder project. I don't know if it's going to happen, but a whole new coding challenge video. It's about 30 minutes long. A lot of production value stuff went into it, which is, who knows if it's a good or a bad idea, but it's coming out this week. It is the video from the Adopt a Function P5JS series. If you're on Nebula or if you're a Coding Train member, you will get to see that early. You can join through YouTube memberships or sign up for the Curiosity Stream bundle that I should probably not be talking about because today's stream is sponsored by Brilliant. If you love the Coding Train and learning stuff from me, I think you'll also love learning from Brilliant. Sign up for free at brilliant.org/codingtrain. Okay, join the Discord, say hello there. I will see you all next time, this coming Friday, probably in the morning. Stay tuned, follow my Twitter, join the Discord, all that. We'll get the announcements. Subscribe and click the bell, I guess. That'll do something. If you want to just there's lots of ways you can get notifications about when I'm live streaming, but really turn off all your notifications. You don't need them from me, but if you wanted them, you could get them. I don't know what to say about that. You probably have too many notifications. It's really fine. You don't need to have another one. Goodbye, everybody. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do. Can't find the right button. This dot. I'm going to do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot, this dot, this dot. This dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot, this dot song. This dot, this dot. This dot, never forget this dot. This dot, this dot, this dot, never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song, never forget the this dot. Somebody compose that song for me. I'm going to say once again, here we go, sing it with me. It's the polar to Cartesian coordinate song. It's the polar to Cartesian coordinate song. Autotune and the internet will fix that for me. Sing it with me. It's the polar to Cartesian coordinate song. 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 Unicorns and rainbows and cupcakes. What else is there? Yes, kittens. Thank you very much. Kittens and rainbows and cupcakes. Notice that, and look what I get. I'm really losing my mind. Okay, let's do it. Kittens and kittens and kittens and kittens, 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 kittens and kittens and kittens and kittens and kittens and kittens, 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 kittens and kittens and kittens and kittens. I feel just sort of like a nice feeling of relaxation. Everything's going to be okay today. Dream is not broken. It has not frozen. This is a wonderful thing. Okay, we're going to do it. I'm really getting to something. I need my sound effect. Unicorns and rainbows and cupcakes. What else is there? Unicorns and rainbows and cupcakes. That was invalid syntax, I forgot. There was one other thing here that I think is important, that I will use continuously over and over again in all sorts of text generation analysis things. That I will use continuously over and over again. The first thing I need to do is, yes, kittens. Kittens, kittens. I'm really losing my mind. Okay, we're gonna do it. Kittens and kittens and kittens and kittens, 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 kittens and kittens and kittens and Das Vidania.